Okay, what we're going to look at today is calculating the hypotenuse in a right angled triangle. Now, we talked last lesson about Pythagoras' rule and that firstly it applies only to right angled triangles. Okay, so if we're doing this, we always will start with a right angled triangle. Okay, so this is a right angled triangle. You can see that it has a 90-degree angle. And the first thing I'm going to do with you is just start by again reminding you that the side opposite that right angle is the side that we call the hypotenuse. Okay, this is the hypotenuse. Okay, the other two sides are just called sides. That's fine. Okay, so if we have a right angled triangle, and we know that we'll call this C, A, and B, all right, which means that our corresponding sides will be, remember, side A is opposite angle A, side B is opposite angle B, and side C is opposite angle C, and that's the hypotenuse. Okay, and what I'll do is, firstly, we're going to start by talking about Pythagoras' rule. Okay, we said in the last lesson that Pythagoras' theorem is that if you square the two shorter sides and add them together, you get the square of the longest side. So we can write that as a squared plus b squared is equal to c squared. And this is Pythagoras' theorem. Okay, so you need to learn this. This formula, you're going to be using it a lot. Okay, this is Pythagoras' theorem. Okay, and you guys know that when we do a question in maths, we always start by writing the formula out, and that especially applies in this case. Okay, so let's start with a triangle. Okay, so we've revised the theory. Let's start by making a triangle. Let's make this one different just to make sure you guys don't get too used to it being a certain way. Okay, we will say that this side is going to be 3 centimeters. This side is going to be 4 centimeters. And this side is going to be X centimeters. Okay, so we always start by labeling the sides. Okay, so always label your sides first. All right, we will call this side C. And for the other two, it doesn't really matter which one's A and which one's B. So we'll put an A here and a B here. Okay, so start with your formula. So we know that, again, A squared plus B squared is equal to C squared. Okay, and you can see that C is our hypotenuse. It's the one that we don't know. Okay, and we're going to find what the length of that hypotenuse is. Okay, if you might remember this from last lesson because we actually already did this one, but we're going to go through the steps of how to do it. Okay, so we know that A is 3, so we're going to put 3 squared plus B is 4, so 4 squared is equal to C squared. Okay, we know that 3 squared is 9 plus 4 squared is 16 is equal to C squared. Okay. Now 9 plus 16, if you add those together, you get 25 is equal to C squared. Okay, and now we want to get C. We don't want C squared, we want C by itself. So to do that, we need to take the square root of both sides. Okay, the square root of C squared is C. I'm going to move that to the, we'll keep it on the right for the moment. So C, and the square root of 25 is 5. So we know our answer is that C is equal to 5 centimeters. And this is all we need to do to calculate the hypotenuse in a triangle. Okay, now this one here, this 3, 4, 5 triangle, so we know that X is a 5. This is one of the special triangles that we have. Okay, we always get a 3, 4, 5 ratio. That is one of the special ratios that we can have. There are a few different ones that you will always get in the same ratio, and this is one of them. So if you get triangle that has, instead of the 3, you have a 6, and instead of the 4, you have an 8, then we always know that that last side's going to be 10 because we've just doubled all the sides. Okay, don't worry too much about that, but it's just a little bit of interesting info. Okay, so let's do another one. Okay, we'll go like this. Okay, we will have 12 centimeters. This is going to be another one of our special ones. 5 centimeters and X centimeters. Okay, and now I hope you're starting to see why we did all this work with square roots last unit. Okay, so again, let's start by labeling the sides. So we have side A, side B, and side C. Okay, so always write the formula first. A squared plus B squared equals C squared. Okay, we know that A is 5, so 5 squared, plus B is 12, so 12 squared is equal to C squared. Okay, 5 squared is 25, plus 12 squared is 144, and that's equal to C squared. Okay, 25 plus 144, that's 169, which is equal to C squared. Okay, and again, we want to get C by itself. We don't want C squared, we just want C, so we need to take the square root of both sides. Okay, and we will get that C is equal to the square root of 169, which you know from last unit is 13. Okay, so we get C is 13 centimeters. Okay, and again, this 5, 12, 13 triangle, that's another one of those special ones that you'll see quite often. Okay, this is it. It doesn't get any harder than this at the moment. Okay, we will obviously be doing some harder things, but this is how to use Pythagoras' theorem. Okay.